said, I'm getting that higher intensity, getting the mitochondrial benefits, because that's how I nerd out. I'm like, when I'm exercising, I have to think of those benefits to keep me going.
Right.
Hey everyone, welcome back to the Reshape Your Health podcast. I'm your host, Dr. Morgan Nolte, and I'm really excited about today's guest who's sharing his time and expertise with us today. Dr. Joe Houmard is a PhD in human bioenergetics, and he's a professor in the Department of Kinesiology, and he's the director of the Human Performance Laboratory at East Carolina University. He's a prolific researcher, and he has numerous publications online that look at, how do different types and intensities and amounts of exercise, and he's predominantly studied aerobic exercise, has studied some resistance exercise. How does that impact our mitochondrial health? How does that impact our muscle health and our fat tissue and insulin sensitivity? And so among his research, Joe, he gave me permission to call him Joe, is part of a $170 million grant funded through the NIH Common Fund to better understand the body's response to exercise. I'm so excited for that research to come out because the goal is to understand how physical activity changes the chemical molecules within the body, which could lead to more targeted types of exercise. So my goal with this conversation today is to shed some more light on, okay, well, we know exercise is good. Why is exercise good? What types of exercise have you found to be most beneficial in the literature? So Joe, thank you for joining us today.
I'm glad to be here, Morgan. Thanks for inviting me.
Yeah. And we were talking offline. I'm like, well, what's the message that you want to share from this? And it was really that there are health benefits to be gained from exercise, especially regarding insulin sensitivity, even without weight loss. And so you mentioned that you speak to diabetes educators about this. And I think that's kind of a nice place to start. But before we get there, I want to hear your story. So I always like hearing people's stories. How the heck did you get your PhD and what you did? And I know that you've been at ECU for a long time and you've done a ton of research. So what drives you to continue that research and what brought you to this place?
Sure. Yeah, just really briefly, in high school and college, I was a distance runner. I ran cross country and track throughout. And so that was at the time of the first running boom. And, I always wanted to try to figure out how to get faster, how to improve my performance. And publications were just starting to come out on that. Again, to date myself, that's when we started finding out that caffeine was good and that things like Gatorade were good. So that just led into, I didn't really know what I wanted to do, but I knew I was interested in that stuff. So I went and got my master's and looking at some aspects of human performance. But the big one was my PhD I got with a fellow named Dr. David Kostel at Ball State, who was kind of the guru of figuring out what made a better endurance runner. And learned a lot of physiology. But then I also realized that, athletes are a tiny component of what we as exercise physiologists should be working with. I mean, it's great, it's fun, but really, there's aging, there's obesity, there's type 2 diabetes. And so I did a postdoc here at ECU to try to find out more about that, to get to the bigger picture. And I guess they liked me. They offered me a job really quickly because I was looking for jobs because my wife was pregnant. I thought postdoc, no, I got to get some money. So they offered me a job and I've been here ever since. It's been a great place to work and raise kids and everything like that.
That's awesome. And I know we were talking offline, you're from Ohio. I'm pretty much from Nebraska. So it's kind of fun to connect with another Midwesterner and just a little bit more laid back, which is fun. So tell me a little bit more about what you have learned. Like, what are some major themes that you've learned in your 30 plus years of research regarding the benefits of exercise?
Yeah. So I think one of the biggest things I've learned and that I try to emphasize when I go out and give talks is that, exercise is definitely like a drug. That's the analogy I use. And if you Don't take a drug. Guess what? It's not going to work. And the things that happen that are good when you take a drug go away really quickly when you stop taking it. So exercise is exactly like that. And in the terms of insulin sensitivity, which I think is one of the most important aspects of health, I mean,
Mhm.
you look on TV, you see this thing called prediabetes, figure out your number and all that. Well, that's prediabetes is just another term for insulin resistance, being
Mhm.
resistant to insulin. And with exercise, you can reverse insulin resistance really, really quickly by just contracting your muscles. And you don't need to lose weight to do that, to improve that aspect of metabolism. So that's one of the biggest things I try to stress. Just get moving, get your muscles contracting. Do not have that, goal at the end of everything to lose 20 or 30 pounds, because that's a little different than what exercise can do for you.
Will you kind of go into the physiology behind why is contracting our muscles so beneficial for our blood glucose and insulin levels?
Sure. So one of the biggest things is that muscle is very plastic. Okay. So when you stress it, it tries to adapt to that stress. And the most common, example that's going to be weightlifting, right? You stress it by lifting weights. Guess what? The muscle gets bigger. Well, with endurance exercise, you're placing a different type of stress on the muscle. And what that does is it improves the way the muscle utilizes energy, primarily through things like the mitochondria. When you're exercising, you want to be able to oxidize or burn and create energy from things like fat. All right. So you become more effective at burning fat. You also deplete stores of glycogen in your muscle, the stored form of glucose. So after you're done, you have to replenish that, which takes glucose out of the bloodstream when you eat it, that makes you more insulin sensitive. So really the changes that occur at the molecular level in skeletal muscle with endurance exercise have to do with adapting to the fuel that you need during and for a little while after the endurance exercise.
Okay. And I think that I read one of your studies, or maybe it was a different study down the research rabbit hole that I'm sure you've been down a time or two. You go to look up one study and then you keep looking up studies. That the beneficial effects of exercise stopped, as you said, pretty quickly. So before we kind of dive into age and obesity and different efficiency of skeletal muscle and fuel usage, let's talk about that first. How fast do the effects and beneficial effects of exercise fade when we stop?
Okay. Now, it's important to stress this is relative to insulin sensitivity.
Okay.
Okay. When
Good point. Yep.
when you stop exercising for a week, you're not going to become obese. You're not going to necessarily lose muscle mass. You won't lose a lot of aspects. But for insulin sensitivity, it goes away really fast, even without regaining weight or anything like that. I mean, when we've looked at highly trained weightlifters and endurance subjects, we looked at them after a week of no training, and it wasn't that different from people that didn't exercise at all in terms of insulin sensitivity. And we've also taken people that we exercise train, who are sedentary, and we'll exercise train them for 3 to 9 months. Insulin sensitivity gets a lot better. But when we look at them, 2 weeks after they stop, okay, they do the exercise, typically people stop, they lose that adaptation really quickly. I mean, and it goes back to almost zero. And
Yeah.
insulin action is one of the important things that's linked with disease states. So with insulin sensitivity, easy come, easy go.
Yeah, I love that analogy of a pill. It's like, well, it doesn't work if you don't take it. So what do you feel like would be the optimal recommendations for insulin sensitivity, in the average population, we'll say?
Yeah. I get that question a lot. And honestly, the answer's not really, really evident. That's a place where a lot of research, is being done. And I think, as a result of that, the public gets confused, right? Because just look on the internet, exercise programs, they're all over the
Yeah.
place. I mean, um, so when I talk to the educators and other folks, I always say something's better than nothing, because
Hmm.
remember, all those adaptations I talked about were muscles contracting. So 10 minutes, 15 minutes, if you can get it contracting, that's going to help you. What we found was in older middle-aged individuals that were sedentary, if we could have them, we call it walking with a purpose, if we could have them walking with a purpose for at least 2.5 hours a week, that really improved insulin sensitivity. Okay. Almost as much as, slow jogging for a similar period of time. Really it was equivalent.
Yeah.
So with insulin sensitivity, it seems to be a factor of time. If you can get out there and do something 2-3 hours a week, spread across a couple days, 30 minutes, 45 minutes a day, not all in one day. We've found that that's pretty successful and also attainable for people, if they
Hmm.
want to get healthier.
Yeah. I have a question for you about aerobic training versus resistance training with minimal rest breaks. So I don't know if I told you this. I'm a mom of two young kids, a 4-year-old and a 2-year-old. And I used to really enjoy some distance running. And then when I had my son, he only lasted like 20 minutes at the gym before the caretaker was like, "Hey, Morgan, your kid's crying and he won't stop and you need to go now."
Mm-hmm.
And so I really had to find the most efficient form of exercise. And at the time, and it continues to be strength training for me. And one thing that I do is really try to lift heavy and minimize my rest breaks so that I keep my heart rate up. Does that count towards this aerobic type of training, or is there a different mechanism regarding like that continual muscle pumping? So I kind of wanted to pick your brain on that heart rate remaining elevated versus the continual muscle pumping aspect of the aerobic quote unquote exercise.
Right. So really, you're kind of talking about circuit training.
Uh-huh.
And, circuit training is a good mixture of aerobic and resistance. Um, but when you look at it, resistance training, it's not just the muscle, right? You're releasing a lot of hormones. And the
Mm-hmm.
hormones that get released in response to resistance training can be quite a bit different than what you see with endurance training. And, when you're looking at the whole body with muscle contraction, it's also a function of the hormones that are released. So, it it's good what you're doing, and you're probably getting a part of an aerobic response, but the nature of the resistance training, you're probably not getting the same hormonal response. And again, it's probably a little different drive to the muscle, more of a hypertrophy drive.
Yep.
But it can still improve insulin sensitivity if that's what you're looking at, right? Other outcomes are going to be a little different.
And that's a really, really good point. So I'm a geriatric PT. I've had other PhDs on here to talk about bone health, osteoporosis prevention. For that, the weight bearing exercise of walking, especially walking uphill, is good, but the resistance exercise is even better for bone
Mm-hmm.
health. And I think reading through your research and kind of piecemealing it together with what I know as a PT is like the aerobic exercise is almost the lowest hanging fruit. We were
Mm-hmm.
talking offline, all you need is a pair of shoes,
Mm-hmm.
walk up and down the stairs, go outside. But if you want to really optimize your health and prevent falls, prevent fractures, have strong bones, improve body composition regarding lean muscle mass, that's kind of where the strength training I think is really beneficial. However, after reading your research, I'm like, I got to get back into the aerobic training too. I think that it's been almost like a time crunch thing. There's seasons of life where you have a certain amount of time that you're willing to dedicate towards your health. And kids are starting to sleep more, which is great. So it's like, oh, I think I can invest a little bit more of my time. And instead of doing more resistance training, I'm going for a jog today. So it's like, I listen, I learn, and I do it. And I also wanted to know, how has all of this research over the years impacted your physical fitness program? Like, what do you do personally?
Right. Yeah. And I think you emphasized it. I mean, the aging process, particularly when you're talking about bone health, muscle mass, I mean, that's when uh, you start losing that. Muscle mass is a natural part of the aging process, and it tends to go away. And even if you are resistance training, you're going to lose some muscle mass over the years, but you're still going to be at a higher level than a person who does nothing, right? So that's it. Resistance training, aerobic training, it's not a fountain of youth, but it keeps you looking a lot younger physiologically than somebody that's similar to your age. In terms of myself, yeah, I know I need to resistance train. That's it. But guess what? Yeah, that's why I ran endurance running and stuff in high school and college and gravitated toward that, because I don't get very big. I don't like resistance training. My mind is aerobic, but I realize the importance of it. And, as I get maybe a little closer toward retirement and get that more time that you're talking about,
exactly.
yeah, maybe I can get in there and do it, because it is important, and it's important to have a balanced regimen, and definitely muscle mass. Muscle strength is never a bad thing to have at any age.
No, and especially as you age. I also think that the role of exercise in mental health is so important. And I don't know if you guys are studying any neurological effects of exercise in this, $170 million study, but I'd be really interested to know if there's a difference between, for example, yoga versus walking with a purpose versus resistance training in dopamine, in, different neurological hormones that impact our mood. What have you seen in the research there?
On that one, I don't know, honestly.
That's okay.
I don't know about that. The little bit that I do know, and it's could be wrong, it's maybe been disproven, but endurance exercise tends to trigger endorphin release.
Right.
Resistance, not so much,
Mm-hmm.
So there's, like I said before, there's definitely differences. When you're talking about mental health and neurological, I think it's undeniable that exercise has been shown to help. And I don't think it's too specific on what type of exercise it is. It's just like you said, probably most of it's going to be endurance, because that tends to be what most people do if they do anything, because it's the easiest.
Yeah. And I think, go ahead.
And there's even more. There's the social aspect of the whole thing,
Oh,
right?
sure.
Walking, you can talk. Resistance training, you got other people around you. I mean, when you start incorporating all that stuff, it becomes a whole lot more than just the exercise itself.
Yeah. And that's a really good point. I wanted to pivot and return to that conversation about skeletal muscle. And can you describe for us what is healthy skeletal muscle versus inefficient, maybe, or unhealthy skeletal muscle? And we can kind of start the conversation there.
Sure. Yeah. So, when comparing the two, healthy skeletal muscle is going to be able to utilize oxygen more effectively. Okay. So it's very easy to see, if somebody exercises with healthy skeletal muscle, they can maybe go a little longer at a higher intensity, because their muscles are more effective in using oxygen to make energy. Okay. Thus, those muscles are more aerobic, which means their mitochondria are more effective in using oxygen to make ATP, to make energies. That's one of the biggest things. And when you go down a little deeper, healthy skeletal muscle is able to utilize both fat and carbohydrate, blood glucose, muscle glycogen, lipid that's secreted by the fat cells that travels to the muscle. It can use that for fuel both at rest and during exercise. So that's kind of one of the hallmarks, is fuel utilization. And healthy skeletal muscle has the ability to be flexible. You eat fat, guess what? That muscle burns the fat. You eat glucose, guess what? It stores the glucose, or it oxidizes it or burns it to keep the muscle healthy. It can switch. It's called metabolic flexibility. You don't see that in unhealthy skeletal muscle. Okay. It's doesn't use oxygen well to make energy. It's more glycolytic. That's one of the bigger differences, is fuel utilization.
Okay. And so just kind of to elaborate a little bit on that, if someone who has healthy muscle tissue eats, for example, a high fat meal, even if it's healthy fat, and they're, for example, maybe eating a lower carb diet, the muscle can use that fuel instead of store it. But if someone's metabolically inflexible, what happens if they have a higher fat meal and they're not eating the carbohydrates that maybe are readily used by the muscle?
Yeah. So we've done what we call Super Bowl weekend studies or Christmas holiday studies or Thanksgiving, right? Where regardless of who you are, you're usually sneaking in some fat there somewhere
Uh-huh.
along the way. So 3 to 5 days of high fat feedings, we've looked at those. And what you see is that in healthy skeletal muscle, they ramp up the enzymes in the mitochondria and everything. They adjust to oxidizing the lipid rather than, letting it go to the fat cells to be stored. Whereas when you put, let's say, an obese individual under that same sort of diet, they don't ramp up to oxidize the lipid that they're consuming. So then you can imagine if it's not being used for fuel and muscle, which is a big user, it's going to go be stored in fat cells. Now that's overly simplistic,
Right.
but the muscle just doesn't adapt to doing what it should do in terms of disposing of that lipid. So it's going to be stored, and it gets stored in places like just not your adipose tissue, but places like the liver, fatty
Right.
liver, right? If your muscle's not doing a good job disposing of fat, it gets stored in the liver, and some even get stored inside muscle itself, which is not a good thing.
Yeah. I like to say marbling is good in our steak, not in our muscle.
That's for
Um,
sure.
and so I think that when I think of healthy versus unhealthy muscle, I think of when I was an anatomy TA in undergrad and in PT school, and I had a love-hate relationship with the cadaver lab because I just loved dissecting, and I loved seeing the anatomy. And you can cut through and you can see muscle that's healthy and lean versus muscle that is infiltrated with fat, and yellow deposits. So will you talk a little bit about the changes in muscle, versus a healthy individual, an obese individual, and then as we age? So let's start with healthy versus a healthy person as they age.
Mhm.
How do we see that muscle tissue change versus regarding, you said lipid oxidation, oxygen utilization, and then fat storage in the muscle?
Yeah. So as you age, one of the biggest losses is that you lose muscle mass. Okay, that's why resistance training is really emphasized
Mhm.
during the aging process. And when you look at it, it's not like people need to be 60 and start resistance training. I mean, muscle mass starts going down as early as age 30.
Yep.
Okay, so that's one of the big things. So I spoke all about how muscle oxidizes lipid and everything. Well, guess what? If you have less muscle, that's less of a sponge or less of a machine to dispose of it, right?
Mhm.
So just by the nature of it, you have less muscle mass, less mitochondria. You're not as insulin sensitive in the whole body. You become more insulin resistant. And, exercise will help with all that stuff. But like I said, it's not going to, you're still going to get some of that regardless of how much you exercise, because that's the other fact of the matter. I mean, you can't do what you did when you were 30 when you're 65,
Yeah.
the volume, the intensity. So that's one of the big things with the aging process. You want to do something, it's definitely healthier, but looking at muscle atrophy, losing muscle is the big thing.
Yeah. Okay. And then how about if someone, let's say that they were at a healthy weight when they were 30, and then we know that people gain, well, not all people, but a trend in America with, over 7 out of 10 adults overweight or obese is that we're gaining weight, as we age.
Mm-hmm.
So let's say they're quote unquote in the obese category by the time they're 50. What's changed in their muscle between when they were lean when they were 30 and obese when they were 50?
Yeah. So, fat, although I don't study a lot, fat in itself sends out lots of inflammatory signals, so a large fat mass is just not good in terms of inducing whole body inflammation. So with obesity, you are also storing, you mentioned marbling, you're
Yeah.
storing more fat around the muscle cells with that too. And so adjacent to the skeletal muscle, you're having these inflammatory marker, things
Mm.
happening because
Yeah.
white blood cells infiltrate, and then there's this whole thing that happens that makes the muscle more insulin resistant. It just leads to that. And there's really no pronounced atrophy with obesity. It's just that skeletal muscle metabolism changes a lot because, unfortunately, with the development of obesity, a part of it might be because people aren't as active.
Yeah.
Okay. So it's kind of double jeopardy. You're getting
Yeah.
the aging response that I talked about. And then on top of that, you're piling on a fat mass, which is not a good thing. And that fat is right next to muscle too and causing all sorts of problems.
Yeah. I think one of the research studies of yours that I read that I thought was really interesting was looking at the different types of exercise as it related to fat loss and like weight loss versus gaining lean muscle mass, because we want to lose weight, we want to lose fat mass, but we don't want to lose our lean muscle mass. So if you remember that study or from other research, how did aerobic exercise fare versus resistance exercise for those outcomes?
Yeah. I can't recall that one as much. Of course, resistance training is giving you the signals to retain muscle mass. So,
Like a boost in growth hormone, those
yep.
kinds of things. Yeah.
Right. So, when you're losing weight, maybe resistance training could be more appropriate,
Mhm.
for if you're just looking at muscle mass. But the key to all that is, the more you starve yourself, the more your body's going to use muscle for fuel, right? So when you hear the recommendations of losing 2 to 3 pounds a week, that's not very exciting. But at the same time, then you're talking about losing fat mass as opposed to, losing more lean mass in proportion.
Mhm.
So, resistance training is good in those respects. I mean, aerobic training, if you look at most runners' calves, for example, they're not small, right?
That's
So,
true. Yeah.
it's just not as robust. You still get some of that, but probably any sort of exercise. But you're right, resistance might be a little bit better, particularly when you're really trying to lose weight.
Okay. And I was surprised. From what I remember, I think the research study said the both are beneficial, kind of like you were alluding to, and that the aerobic was almost more beneficial for the fat loss, but then the strength was more beneficial to reserve or to preserve lean muscle mass, which we know is good for long-term, fat loss. And so it was kind of like, okay, so both is good.
Yeah.
Both is important. So what do you feel like? I think it was a really interesting point that I didn't want to overlook when you said it was more the volume than the intensity that improves insulin sensitivity. Will you kind of speak to that? Because that was pretty encouraging to me. And I think to anyone as they age, if they feel like I'm not doing as much as I used to.
Right.
Can you speak to that?
Yeah, this is a study called the STRIDE study that we did with Bill Krause at Duke. And it was a pretty large study. And we focused primarily on people now that we would say look like they had prediabetes, age 50, sedentary, maybe their insulin values are high, they're overweight, maybe, right on the cusp of obesity. And we wanted to look at 3 exercise prescriptions. And basically, one was walking about 12 miles a week, which was the 2 hours, 2.5 hours,
Mhm.
I hope I'm getting this right. One was jogging 12 miles a week, and then another was jogging like 20 miles a week.
Yep.
Okay.
Yep.
And the good news is that we found that the walking was just as good as the jogging. And the common thing that those two had in common was simply the fact that they did it for about 2.5 hours a week. Okay. So, in other words, it was the time that you were exercising, not necessarily that you were jogging or walking with a purpose, if that makes sense.
Yeah.
Now, that might be very specific to the population we looked at.
Yep.
and very specific to the exercise paradigms. These weren't, huge, big increases in exercise volume or something, but they are what was recommended.
Mm-hmm.
So at least for insulin sensitivity, I mean, there was lots of other markers that the high intensity exercise favored,
Yep.
no doubt about it. But for insulin sensitivity, it looked like, and this is what I tell people, the minutes per week you can do it is the important part.
Yeah. Will you touch on what were those other markers that were good? Because I read it, but I can't remember. And it's like, that's why I got to go jogging, because I want those benefits of the higher intensity training. Where was it 60 to 85% of your max heart rate?
Yes, it was something like that.
Okay.
Right. So, early on, we talked about how aerobic exercise is a stress,
Yeah.
So guess what? If you stress the muscle more by going more intensely, your mitochondria are going to become better at using oxygen. So things like your VO2 max, your maximal aerobic capacity will go up more if you do more intense exercise for a longer period of time. That's one of the big ones. Your aerobic capacity increases.
Mm-hmm.
I think the other one that we saw, again, exercise isn't a great thing for weight loss,
Yep.
but you're expending more calories if you're jogging for 30 minutes as opposed to walking for 30 minutes, right?
Mm-hmm.
And so with that, you're going to get some weight loss
Mm-hmm.
and you're going to get some fat loss. And that will be accentuated, essentially, the more energy you burn by doing harder exercise for a longer period of time.
Yeah.
Again, not a lot, but one of the big things we saw, particularly in the men, was that higher intensity exercise was pretty effective at reducing belly fat. Not necessarily overall fat so much. We exercised people in that study for 9 months, and I think on average they might have lost 3, 4, 5 pounds.
Right.
But
Yep.
the good thing was the fat was lost from the bad place, which was the stomach.
The visceral, yeah, the stuff that you can't grab with your hands.
Right.
I don't know if you've researched this, but the hormone adiponectin, I think that I've seen before that that's one hormone that increases with exercise that preferentially causes fat to be stored in the subcutaneous versus the visceral. So that might be one hormonal adaptation. Are you aware of any other, physiological reasons why the exercise may be beneficial for visceral fat?
I think you touched on it. Visceral fat is what we like to call metabolically active.
Mm-hmm.
So it's inside your stomach cavity, right? It's right next to the liver. It dumps its fats into the liver. So when you're talking about things that, like aerobic exercise, where the hormones are secreted that let's release fat so the muscle can burn it so we can keep going, that metabolically sensitive intra-abdominal fat is where it's going to happen. Okay. Now, on the flip side, that's why intra-abdominal fat is also not good, because of primarily the location. And, it's dumping fats right into the liver. It goes right into the hepatic portal system. And it's also releasing fatty acids at a lot higher rate than subcutaneous fat, just because of its location. So it can go away, by being metabolically active, but also it's very negative due to this metabolic activity in terms of dumping bad things into your circulation.
That makes a lot of sense. I have to ask you this question from an adherence standpoint. The studies that you perform have pretty long intervention periods, 3 months, 8 months, a lot of like 8 months, 9 months, where you're recruiting sedentary people to start exercising, sometimes at the caloric equivalent of jogging for 20 miles a week. How are you doing that? How are you getting people to stick to something for that long, especially when it's new to them?
Yeah. Well, for one thing is, of course, we ramp them up.
Okay.
It might take them 3 months to get to that point that I spoke about.
Uh-huh.
And I use jogging as an example, but, probably in most of the people, they just put the treadmill at a bigger grade,
Yes,
right? To
that's
get
important.
that
Yep.
higher intensity, and they don't have the impact and everything. It's just not as graphic a demonstration in your head. Some people like to jog. I mean, we got some people to run their first 5K. I mean, that was all fun to have them shoot toward that goal, right?
Mm-hmm.
Um, it's tricky. we do lose people. Commonly, we lose people because, it's the time constraint. How do we keep them going? How do we keep them motivated? We do the little things like making parking easy, accommodating their schedule. We have students, and we have the students exercise train individuals. And, when you're talking 50, 60-year-olds, it's like that. They like the interaction, with younger folks and talk, and sometimes they become attached. So it's little things like that. And then also, honestly, in the bigger studies, you do get paid.
Get
So
paid to
there's a little,
exercise.
yeah, there's a little bit of a monetary reward. But if you asked most of the people in this study, they're like, no, I'm not doing it for the money.
Yeah, it's not that much. So if someone's listening, like, I'm going to make money and, call Joe and be in this study, it's like, it's not that much money probably, but
yeah, it's not, but a little bit helps.
That's true. So there is a ramp up phase, which I think is an important thing. And then I cannot remember what it's called for the life of me. I had a really awesome personal trainer on who had both hips replaced and a back surgery and all this stuff, but he really enjoys to increase the intensity of his walking, weighted vests. And so you could put that on, you could walk at an incline. You don't have to be jogging to get this high intensity. So I think let's kind of differentiate high impact versus high intensity for people that are listening who are maybe fearful of the jogging thing that I'm talking about, that I'm going to do after this interview.
Sure. No, I think you're exactly correct. Yeah. It's just getting your heart rate up there higher, and you got to do something different other than you can only walk so fast and get it up so high.
Right. And so the moderate intensity, what is it? 50 to 60% or so of your max heart rate.
Usually you're falling in there, right?
Okay. And then the higher intensity is like 60 to 85. Now, for the novice listening, what's a simple way that they can calculate that maximal heart rate so that when they're exercising, they can check it really quick in the gym and they can say, all right, I'm doing what Joe said. I'm getting that higher intensity, getting the mitochondrial benefits. Cause that's how I nerd out. I'm like, when I'm exercising, I have to think of those benefits to keep me going.
Right. Yeah. Honestly, the best way to do it is to have a maximal stress test, where you actually make yourself, go to where you almost can't go anymore. And that's your maximal heart rate, because the classic way was 220 minus your age. And with that, it's a good ballpark. But when you look at it, that can be plus or minus 10, 15 beats. So there's quite a bit of error linked with that. You can use that as a ballpark. It's better than nothing, right? Yeah. But if you really wanted to do it, you'd work with an exercise physiologist or maybe somebody in the gym and just have you increase let's say the grade on a treadmill until you've got to stop. And then you look at your heart rate.
Okay. I can't remember it, but there was another formula that I learned when I was studying for my geriatric clinical specialty. And it could be unrelated, the carbonin.
Ooh. Yeah, that could be from a step test or something like that. Or there are prediction equations, like you would track your heart rate, let's say over 3 mild intensities. And since it's linear, you should be able to predict your max heart rate. But again, with any prediction thing, it all depends on the population that you made the prediction in.
Yeah.
And a lot of that is young college age students, because guess where we do our research?
There.
Yeah,
People who want a little bit of money and who have some free time.
That's right.
But that 220, that minus the age, I think that it maybe overestimated it for younger individuals and underestimated it for older individuals.
Right.
So what I'll do is I'll look up whatever formula that I found when I was studying for the GCS, and I'll put it in the show notes for this, for people who are really want to nerd out and they want a better equation than the 220 minus your age. And then just to kind of finish that thought, it's 220 minus your age would be the maximum. And then you take that number times, 0.65, and that could be the low end of your high intensity range. Take that, 220 minus your age times 0.85. That might be the, up to 85% of your max heart rate. And that's how you know that you're working in that higher intensity. And I think that this is an important conversation too, And maybe, as you said, you don't work with this population as much, but I know in geriatric PT, if people are on a beta blocker that blunts their heart rate, or maybe they have a pacer and then they're set at 80 beats per minute. We used a Borg scale, so like a rate of perceived exertion scale. Have you seen anything else in the literature that might help people who are on a blood pressure medication, maybe that blunts their heart rate, to kind of gauge their intensity of exercise?
Yeah, you're right. Because heart rate isn't always the best to do it, right? I mean, it's the
Yeah.
easiest. We have heart rate monitors and all that. I mean, a big example is, think about if it's getting warm down here in North Carolina, you go out in the heat, your heart rate's going to be a lot higher, even though you're doing the same thing, you know? So, uh, like you said, ratings of perceived exertion are usually pretty good. I mean, I think, earlier on, I talked about walking with a purpose for 30 minutes, right? That hours per week might be the most important thing. So regardless, if you make all these calculations and you only can do it for 5 minutes, you're probably going too hard, you know?
Yes.
So I think that's another way to do it. When you're done with the allocated time, you shouldn't be throwing up and falling down or anything like that. You should be tired though. So these perceptions that you were speaking about, I mean, they're probably a lot more accurate than what we think. But again, the big thing I think is time. You just got to get that in there, and heart rate is part of that equation.
That's an interesting, I never really, it's a simple thought, but I never thought of it. How when I'm strength training, what I use to gauge my intensity is my reps. And if I'm not at fatigue, failing after 12, I feel like I need to up my weights. I'm outside of that moderate to high intensity where I want to be to really build strength.
Right.
And I think it's interesting. You can kind of use the inverse of that for aerobic training. If you can't do 30 minutes of an activity without, feeling like you're going to pass out, maybe we need to back off the intensity.
Mm-hmm.
And obviously anything is better than nothing, as you said, but that's a really interesting way to think about it.
Well, the easiest thing is just the talk test. Go out with somebody else, and if you can talk to them without taking big gasps or something, you're probably close, about where you should be.
Yeah, I know. I've really enjoyed quote unquote mountain biking in Nebraska as much as you can. There's like, a couple hills around here. And that's a really fun form of aerobic activity. I have to stop and catch my breath. And to me,
Sure.
that really tells me, okay, I'm working at a pretty good intensity here. So
Mm-hmm.
if you feel a little bit of short of breath, that's okay. I think there's also that misconception where people are afraid to feel a little bit short of breath, like especially if they're novice exercisers, they might think that something's wrong. Any advice that you have, for the novice exerciser who's maybe a little bit intimidated by the conversation that we're having, and they're thinking 2.5 hours of exercise a week, there's no way I can get there. What would you tell them?
Yeah. First of all, I emphasize, there's a lot of empathy for time per week. I mean, exercise it's hard to fit in. You just have to view it as part of an investment in your health, right? Mm-hmm. And like I said, if there's a social aspect to it, if somebody's waiting for you, that helps with all that. I think that, we have these perceptions of aerobic exercise, that we're doing it to lose weight, that it really needs to be intense, and that we're suffering the whole time. And, at the end, we're just exhausted. It doesn't have to be like that. Mm-hmm. It doesn't have to be like, walking the dog crazy slow. But, you want the intensity up there. It should be something manageable. And a little rule that we always did is that when you're done, you should always kind of feel like, man, I could have done maybe a little more. Mm-hmm. Right. That's, again, these are about as non-scientific things as I can tell you, but
it's applied science. Yeah.
Yeah. So it doesn't need to be this crazy all out stuff, mm-hmm. to get benefits. So I don't think people should be intimidated. And there's lots of tools, and we have the internet out there that can, help with people too, if they do have questions.
Yeah, that's true. I had one more topic that I wanted to discuss based on what I saw from your research, and that's exercise in pregnant women. So maternal exercise and how that can impact the health of the baby. Did you want to speak on that at all? I did not read those research studies in depth, but I just, I'm a young mom and I have friends who plan on having more kids. And so I was just curious because when I got pregnant, there was some fear around that. And there was some fear that I don't want to hurt my baby. I don't want to work too hard. I don't want to, but I also know for me, it's a mental health thing.
Mhm.
And so I wanted to hear your thoughts on that from what you found in the research.
Well, I have two really good collaborators here in Linda May, who's been doing this for a long time, and Nick Broski. And I can tell you that Linda's looked at, she brings in people that are sedentary. And I think at about 3 months, 2.5 months, she'll start them on exercise training. And it'll either be aerobic or resistance or a combination of both. And she keeps them within, I can't remember the recommendations, but they're within recommendations. So that is a big misconception. The thought used to be that, if you're exercising before you get pregnant, yeah, you can continue. But if you get pregnant and then start exercising,
Mhm.
that's not the way to really do it. And that's not true. I mean, you're
Mhm.
not going to be running marathons, obviously,
Yeah.
but no, it's acceptable. It can be healthy. There are recommendations out there. And of course, it's good for the mom, but we're just starting to look at what happens to the baby. And I know Linda's research is, and other people, that, sometimes the babies are a little leaner, but more importantly, they stay lean maybe a little later into their lifespan.
Mhm.
That's the sort of things that are happening. Um, what we've kind of looked at recently is that we get cells from the umbilical cord, which represent the baby. And we see that in moms that exercise, those cells are very different, than in
Really?
moms that are sedentary. And again, we're just touching on that, but we're realizing, and a lot of people are beginning to realize, that exercise imprints the baby in certain ways that could look like they can be advantageous. But we just don't know much about that in humans. There's been a lot of studies done in rats and other animal models, but in humans, it's just kind of starting.
Yeah. Are you able to elaborate on like how the stem cells are different or not
Yeah.
much past that?
Let me recall, because this is all so recent,
Yeah.
is that um, I think we saw that in the cells from mothers that were, sedentary and maybe a little more overweight, that those cells were again programmed to storage. Okay, these stem cells were programmed to store. All
Mhm.
right, which these stem cells go off and later in development become fat cells.
Yeah.
So maybe you're, and you think about it, for a baby in the womb, that's great. You want that baby to store
Yeah.
energy and get bigger and all that. But it might not be so helpful, when they reach teenage years. But so exercise looks like it impacts the metabolism of these cells. And we don't really know how it affects later years of age, but it looks like it might be beneficial.
I think that alludes to the genetic predisposition for obesity as well. We know
Right.
there's a genetic component. It's not solely lifestyle. It is, you can't really choose your genes, but I think it's helpful to be aware of that and to kind of think back, well, what were my mom's health habits? Am I set up to store or maybe burn and I think it just helps people be more cognizant of their choices and how maybe some genetic components might influence them to be a little bit tighter around their lifestyle.
Right.
I think that the main point of this conversation in my mind, it alludes to something I heard from Dr. Gabrielle Lyon, and she says, you can't out exercise a bad diet. You can't out diet no exercise. And I think that there's a lot of people out there who try to do that. They try to out exercise a bad diet.
Right.
Can't do it. They try to out diet no exercise. You can't do it. You get different hormonal benefits. And I cannot wait to see that big research study come out on that. And my last question for you is, what would you love to research? Like, what do you see 10 years from now? Like, what do you feel like would just light you up if you could research it?
Wow. I haven't honestly thought about that. I'm just trying to get through this
People have
week.
this other
You know, get to the next week when
a
they
burning
try to get done what I
question.
have. I
Uh-huh.
honestly haven't thought about that. You know, I think what would be really great, and it's probably going to be almost impossible, but what's the exercise prescription that you could use to improve insulin sensitivity that would be a one size fits all? I
Mhm.
mean, this is America, right? We want to get the most bang for our buck in the least amount of time possible.
Yep.
So if we could figure out, here it is, this is one that we are really sure that will work. And it might be different for a 30-year-old, it might be different for a
Right.
50-year-old, right? To find these optimal exercise prescriptions. And
Yeah.
then the other side of that is also that, you know, exercise, weight loss, everybody responds differently. So if there's a way that we could predict that, this person should be doing resistance training because they don't have the genes to respond to endurance training, you know, and so we're going to target them to resistance training. I think that would be really cool to be able to do that because it's targeted medicine, and
Yeah.
that's a very real thing. I mean, when you look overall at exercise, aerobic exercise, it's always helpful, but that's the average. There's some people that don't respond and some people that over respond. So I
Mhm.
think we need to keep that in mind. And if we could figure out markers of that, I think that would be great.
That's awesome. Well, I really appreciate your contribution. Thank you for sharing your time and expertise today. We'll be sure to link up some of the studies that we talked about and you and other resources in the show notes. Any last words that you wanted to share before we
Uh,
wrap it up?
I think the thing about the moms exercising is really important. There's this field called epigenetics,
Yeah.
and you mentioned you got your own DNA and all that, but they're finding out exercise can do some good things, even in relation to your DNA. So, in all, I mean, it's been a great field to exercise. Hopefully, we're helping people, and I think podcasts like yourself, where people maybe get more of the basic good information, helps.
Yeah, kind of let's talk about the research and how it applies to real life. And hopefully if you're listening today, this was a little bit of a motivator to maybe up the exercise dose up, aim for that 2 to 2.5 hours a week to improve insulin sensitivity. If you're not strength training and you're tired of me telling you to strength train, well, here's another reminder. So thank you so much, Joe. It's been a pleasure.
All right. Thank you very much.
Okay, yeah, bye.
Bye bye.